Process Safety and Loss Prevention Integrated Project, Continuous Production of Fatty Acids and Soap, Group 2H. Introduction. Hi there, today we are going to take a look at the production of fatty acids and soap, fatty acid being palmitic acid and soap being sodium palmitate. This is the process flow diagram where palm oil and water are fed. Sodium hydroxide are later added with the palmitic acid produced to form soap. This process involves reactors, flash drums, hydrolyzers, mixers, heaters, expanders, coolers and other equipments to have a continuous process of fatty acids and soap's production. As can be seen in the process flow diagram, there are a lot of unique machineries, equipment, appliances, tools which are surrounded by the workers. The presence of hazards are everywhere, and these hazards are anything that can harm the people, plant, and the environment. Therefore, process safety and loss prevention is important in this processing plant. The main objectives for process safety and loss prevention are: first, hazards identification for the selected processing unit; second, hazard study; and lastly, the recommendations to improve the safety aspects of the selected separation unit. Hazards identification. But which unit to select? Let us choose the flash drum. The flash drum is S100, which separates the fatty acids from glycerol and other components. What hazards are present in this unit? Temperature hazard. This unit operates when stream is at 360 degrees Celsius, and a high temperature will cause heat stress and burning among workers. Next, it might also alter the mechanical strength of the unit, causing component release, which may end up to an explosion. Next, pressure hazard. The deviation of the pressure due to the failure of the expander can change the pressure entering the unit up to 4101 kPa, causing overpressure. The unit rupture might occur and vapor cloud explosion might happen due to glycerol having low boiling point. Next, uncontrolled flashing might also cause the overpressure, and these pressure hazards can affect the plant and the safety of the workers. In addition, flammable hazard. Glycerol is present at 41.03% and is flammable. The stream in this unit is at 360 degrees Celsius, and a fire could break out if there is a leakage with the presence of an ignition source. Next, the stream coming out of this unit contains mostly palmitic acid and is flammable. It will burn easily and releases toxic gases. Hazard study. The guide word is high temperature. The possible cause: low cooling water flow. Possible consequences: too much inlet stream of this unit vaporizes, causes incomplete separation. Next, vapor overload, which exceeds the volume of the flash drum and may cause explosion. Action required: installing a high temperature alarm before the flash drum. Low temperature. The possible causes is high cooling water flow. Possible consequences: low separation, and the action required is to install low temperature alarm. High pressure. Possible causes: blockage in the outlet, existence of cavitation, and high temperature. Possible consequences: overpressure, explosion, liquid level decreases, and induced BLVE. Actions required are installing high pressure alarm, regular maintenance, and installing pressure and temperature controller. Low pressure. Possible causes: leakage of liquid, low temperature of feed. Possible consequences: low recovery and increase of liquid level. Action required is installing pressure indicator and installing pressure and temperature controller. Next, more flow. Possible causes: inlet throttling valve fails open. Possible consequences: incomplete separation, and actions required are installing fail close valve, and operator needs to check the valve condition regularly. Next, less flow. Possible causes: inlet throttling valve partially opens and the leakage of the inlet stream. Possible consequences: low flow of product stream and low recovery. Actions required: install pump and install a low flow alarm. High level. Possible causes: low or high temperature of inlet stream. Possible consequences: liquid level in the flash drum increases and complete separation. Inlet stream vaporizes, may cause explosion. Actions required: install temperature controller and high temperature alarm. Low level. Possible causes: blockage at the inlet, leakage in the flash drum. Possible consequences: explosion at the inlet and low recovery. Actions required: install high pressure alarm and install low level alarm. What are the recommendations to improve the safety aspects of the flash drum? Temperature deviation: you can install the temperature sensor to detect the temperature of fluid from time to time, and a controller to control the flow rate. Next, we can also install a cooling and heating jacket which functions based on the control system and based on the temperature change. If all the safety aspects fail, the sensor can send a signal to the main control panel to shut down the equipment immediately. As for overpressure, installing a pressure controller, and this pressure controller can close the corresponding valve, open a bypass, or perform other instructions to protect the separator. And if this fails, the second alternative is a pressure safety valve should be used, and this safety pressure valve will be open, relieving the overpressure in the separator. And if all fails to operate, a safety head can be used, and this is a device which will rupture when there is an overpressure in the separator. For fire and explosion, spraying inert gases to reduce the possibility of a fire breakout. Next, a flame arrestor can be installed in the pipe to prevent larger fire and explosion. Next, explosion-proofing barrier could be also installed to prevent further damages. For blockage of stream, blockage can be prevented by making sure there is no deposition of components to the unit. Therefore, external heat source is required if the plant shuts down. As for leakage of stream can be avoided by using stronger materials, supportive material at the junction of pipe, and installing a leak detector. So now we are reaching the end of the video, but wait, let us do a conclusion of this entire process. The continuous process of fatty acid and soap production seems to be simple, but it includes a lot of processes which requires the process safety and loss prevention. Let us look back at the objectives and conclude. In this video, we have successfully identified the hazards for the flash drum. We did a hazard study by doing the hazard table to analyze on the hazard and operability study, and we also provide recommendations to improve the safety aspects of the flash drum. So that's all for now, and therefore we should always understand the importance of process safety and loss prevention to make our world a safer place to be. Thank you very much from Group 2H.